Okay, so now let's start discussing sorting arrays. Up to this point, we have been concerned mainly with tools to access and operate on array data with Numpy. And this lecture and upcoming lecture covers algorithms related to sorting values in Numpy arrays. These algorithms are a favorite topic in introductory computer science courses. If you have ever taken one, you probably had dreams or, depending on your temperament, and nightmares about insertion sorts, selection sorts, merge sorts, quick sorts, bubble sorts, and many, many more. All are means of accomplishing a similar task, sorting the values in a list of array. So for example, a simple selection sort repeatedly finds the minimum value from a list and makes swap until the list is sorted. We can code this in just a few lines of Python. Import numpy as np def selection sort in range len swap I plus np dot arg min x square bracket I then colon. X equals to x x return x. Now x is equals to np dot array 2 1 4 3 5 2 1 4 3 5 selection sort. This will result in 1 2 3 4 5. So as any first year computer science major will tell you, the selection sort is useful for its simplicity, but is much too slow to be useful for larger arrays. For a list of n values, it requires n loops, each of which does on the order of n comparisons to find the swap value. In terms of the big O notation often used to characterize these algorithms, you can see big notation. So if you double the number of items in the list, the execution time will go up about a factor of 4. So even selection sort, though, is much better than my all-time or everyone's all-time favorite sorting algorithms, the BOGO sort. Let's discuss BOGO sort. So while v dot x minus 1 x np dot random now x is equals to np dot 21435. BOGO sort. This results in this. So this silly sorting method relies on pure chance. It repeatedly applies a random shuffling of the array until the result happens to be sorted. With an average scaling of, let me show you that, That's n times n factorial. It's basically that all square bracket. This should quite obviously never be used for any real computation. Fortunately, Python contains built-in sorting algorithms that are much more efficient than either of the simplistic algorithms just shown. We'll start by looking at the Python built-ins and then look at the routines included in the NumPy and optimized for NumPy arrays. So now let's move on to the fast sorting in NumPy.